Hello everyone, I hope you're all doing great. In this short video I want to explain you how you can replace NA values in a pandas data frame with the forward fill method including a factor. First of all, we are going to import pandas and numpy, and then we just create a simple data frame to visualize our example. And as you can see here, data frame 1 contains 4 columns, and here within the columns I just specified numpy nan values. We actually want to replace the NA values in this data frame. We do not only want to replace the NA value by the previous value, so we don't want to have here a 1, but we want to replace the NA value dependent on a factor. In this example I will use 0.9 as the factor, which means that we want to put here a 0.9, and down here we want 3 times 0.9 equals 2.7, and also in this case here we want to replace it by -9 and here -8.1. Okay, so for that we are just going to use the forward fill with a factor, and here I actually decoupled the different steps so it's more clear what's behind the code. First of all, we create different base groups, and here you see what it means. So first of all we use the df1, which is up here, and we use the function not NA, so each number which is not an NA value, and we just use the cumulative sum. And when we look at the data frame groups, then you see always when we have a new number we add +1. Here you see 5, 6, 7, 8, always we add +1. And here from -9 to -10 we switch the number and we add here +1, and here the number stays the same. And in the next step we want to get the exponent of the factor. So we actually want to know which exponent we need to use for the factor. And down here what would be the result is we want to have here the exponent 1, which would mean we take the factor to the power of 1. Here we also use the factor to the power of 1, and in these two cases down here we use the factor to the power of 2, just because we have 2 NA values in a row. We actually do this with apply and the lambda function over the columns, and we use there the isNA function with the group by groups of the column name, which just calculates the cumulative sum of the different groups. So here we are within the different group, we add +1, we add +1 here as well. And when we go a step further, we use the normal forward fill function, so the ffill function, and we multiply that with the factor of 0.9 to the power of the exponent. So as you remember, we had here an NA value, and we didn't want to replace that by 1, but with a 1 times the factor of 0.9 to the power of 1, which is 0.9. And in this case, we also use the same factor of 0.9, so we calculate 3 times 0.9 to the power of 1, which is 2.7. Then here we also had an NA value, which means we calculate -10 times 0.9 to the power of the exponent 1, which is -9. And here we had the same thing, so we had -10 times 0.9 to the power of 2, which is -8.1. So in this case you just replace the NA values with a forward fill with a constant factor, regardless whether your number is positive or negative. In the next part, we look at the factor conditional on the sign. So we actually want to differentiate between column 3 and column 4. Here we have a negative number. In column 4 we have a positive number, and we actually want to use a different factor for that. In the positive case, we still want to use the factor 0.9, which would be here 15 times 0.9, which is 13.5, and in this case we actually want to use the factor 0.7, which would mean the number here would be -7. As above, we create groups so we know where we get a new number. Second, we also want to get the exponent of the factor, which means here we need the factor to the power of 1, here as well, and here as above we need the factor to the power of 2 for the second NA value. Next, we just use the normal forward fill fill method with the fffill, and here you see we just forward filled all the NA values with the default value, which is just the previous value from above. And down here we actually define the factors. So we have a positive factor of 0.9 and a negative factor of 0.7. So we want that the negative numbers change faster over the different rows. Next, we also need to specify a positive mask and a negative mask so we can differentiate between the two cases. And the positive mask would just be the data frame 2 up here, all the entries which are bigger than 0, which gives us the data frame back here with true and false. So we see here column 3 is a different case. And the last step actually is to include the factors and the exponent from above. So what we have is the positive factor, which is 0.9 to the power of the exponent, which is what we had up here. And then we multiply that with the positive mask. So we apply the positive factor with the exponent only on column 1, 2, and 4. And for the negative column, which is only the column 3, we use the negative factor, which is the 0.7 to the power of the exponent from above times the negative mask. So we only do that for the negative mask, which would be just for column 3 a true. And you see we replace the NA value here with a 0.9, which would just be the 1 times 0.9 to the power of 1, and here 3 times 0.9 to the power of 1, which is 2.7. And here we actually use a different factor, which was 0.7, so minus 10 times 0.7 to the power of 1 is minus 7, and 10 times 0.7 to the power of 2 is minus 4.9, and so on. And as you can see here, we use multiply equal just because we use here an object on the left side and the same object on the right side, and we multiply that with another object. If you got some value out of this video, it would really help a lot if you like the video and subscribe the channel for more useful content in Python. Thanks a lot and see you next time.